Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you understand how to sketch graphs of circles. So first of all, let's talk about this. This is the general form of the equation describing circles. I'm going to assume that the people watching the video is familiar with this. If you're not, just go back. I've got a video on where this comes from. And go back and have a look at that. The important thing here is that once you have a circle written in this form equation-wise, the center of the circle is at the point HK, and the radius is equal to R. You get it from that. So here we have an equation here. That's the equation of a circle. You can identify the center of the circle by looking at this term and this term. If you compare x minus h to x plus 3, right, you'll see that h must be minus 3, right? Not plus 3, minus 3. Again, this is x minus h. In order to make that an x plus 3, h would have to be negative 3. We get the k value by looking here. Now you'll notice there's nothing here. You could think of that term, if you want, as y minus 0 squared. Right? And then comparing that to y minus k, k would have to be 0. Boy, this does not write as well as I would like. K would have to be 0. Right? Then we compare r squared to 25, so with this circle r has to be 5. All right, so now what we do is we go to our circle, or I'm sorry, we go to our graph here, and we go to the center, right? Negative 3, 0. So 1, 2, 3, 0 is here. This is not actually a point on our graph. It's not actually on the circle, but it's a point we'll use to go ahead and sketch the rest of it. Since the radius is 5, we know if we go 5 units in any direction, there's a point on our circle. So 1, 2, 3, 4, 5. Right? You can see clearly that's the point 2, 0. 1, 2, 3, 4, 5. Right, and that's the point negative 3, 5. I'm going to go ahead and write that one in there. 1, 2, 3, 4, 5. There's another point. What would that one be? Let's see, that one was negative 3, 5 more. Negative 8, 0. That's that point. Then 1, 2, 3, 4, 5. That's negative 3, negative 5. And then you basically connect the dots. If I took the time to use like a circle tool here, that'd look a little nicer, but oh, good enough, right? It's not great, but good enough. And there's a sketch of my graph. I'm not going to do it because I want to move on to do other examples, but if I wanted these points, the intercepts, right, you would put 0 in for x, solve that for y. It's not too tough a problem. But I'm going to go ahead and move on. I've got a sketch of my circle here, so go on and look at another example. Oh my, all right. So this guy right here, this x squared plus y squared plus 4x plus 2y plus 1. This one's going to need a little work. What we need to do first is we need to make this look like this. And we're going to use a process called completing the square. Typically the first step here, let's rewrite this and group the x squared, the x's together. So we'll have x squared plus 4x. I'm going to leave a little space here and you'll see why in a minute. All right, plus, all right, y squared plus 2y. Leave a little space, equals, and if we put this to the right, negative 1. So there's already been a little work done here. I've grouped the x's, group the y's, put any constants over on the right. All right, if we look at that form we're trying to get to. X's, y's, numbers on the right. All right, so now what we're going to do is we're going to complete the square on these two terms. And again, the idea is we want to write this as x plus something, the quantity squared. And the million-dollar question is, what is the something? Well, the outer and inner terms have to give you a 4, right? So they have to be 2. So that, if you did the outer and inner terms, if you FOIL this, you'd get a 4x there. But when you do the last term, you would end up with a 4, and we don't have a 4. what we'll do is we'll fix that by going plus 4. Now, what I've essentially done now, though, is this equation here has been, how do I want to put it, tilted left. I've added 4 to the left. To maintain equality, I have to add 4 to the right. I don't have room to do it, so I'm just going to add it right down here, plus 4. Should have left myself more room there. All right, so these are now equal. We have completed the square. Adding that 4 turned this into a perfect square. Let's take a look at this term. And again, we want to write it as y plus something, the quantity squared. In order to give me a 2y, right, and you have to understand how FOIL works, the outer and inner terms would have to be a 1 here. But the last term would be plus 1, and we don't have a plus 1. We'll just supply it, plus 1. But again, I've kind of tilted this equation to the left, so to speak. It's now has a plus 1 here. That's made it so that these are no longer equal. I'll fix that by adding 1 to the right-hand side. Again, these are supposed to be like here and here, right-hand side of this. Y squared plus 1, or y squared plus 2y plus 1 now factors into this. And then, let's see, negative 1 plus 4 plus 1 is 4. All right, so I've now written this in standard form. Now we'll compare x minus h to x plus 2. H has to be negative 2. Then we'll compare y minus k to y plus 1. K is equal to minus 1. And then compare r squared to 4. R has to be 2. All right. Now we'll go ahead and graph our circles here. We'll start by going to the center. Let's see, 2 to the left, 1 down. There's where our center is. And again, that's not a point on the graph, but that's kind of our starting point for graphing it. Now, since the radius is 2, we know that if we go 2 to the right, there's a point, and that would be, what, 0 minus 1. 2 up, that one would be negative 2, 1. 2 left. Let's see, that one's going to be negative 4, negative 1, and 2 down. And that one's going to be negative 2, 1, 2, 3, negative 3. And now we'll connect the dots. Not the best circle I've ever drawn, but we'll call it good enough for now. All right, I think I got another example coming up here. Yeah, let's try this one. All right, first, group the x terms. This time I'll try to leave myself a little more space. X squared plus 3x plus something, leave a little room. Group the y terms. Y squared minus 2y plus something, leave a little room, equals 1. Now the idea is we want to turn these into perfect squares. So it's going to be x plus something, the quantity squared, and y plus something, the quantity squared. And again, what goes here? You look to that term right there and cut it in half. It's going to be 3 halves. Squared is 9/4, so we have to add a 9/4 to both sides. Okay, by adding 9/4, what we've done now is we've made this equal to this. And go ahead and try it. FOIL this out, first, outer, inner, last, and you'll find it'll add up to that exactly. All right, to complete the square on this, you look here. Take that value, cut it in half. That's going to be minus 1. That's what's going to go here. But the last term here would be plus 1. So we need a 1 here so that these are equal. That's just how you complete the square. You look at the middle number, cut it in half, square it, add it to both sides. All right, right-hand side, let's see. 2 and 9/4. Let's see, that's 8/4 plus 9/4. That's 17/4. All right. I'm just going to kind of double check that. Let's see, 1, 3 halves squared, 9/4. Yep. 1, 2. Yep, I think we're looking good. All right, so the x coordinate of the vertex is minus 3 halves. You get that by comparing x plus 3 halves to x minus h. The y coordinate of the vertex is 1. You get that by comparing y minus 1 to y minus k. All right, so this is h, this is k. The radius, all right, now this is not a nice even square here, so I think what I'll do is just get a decimal for this. If you don't mind, give me a moment here. Okay, 4.25. What's the square root of that? I need a moment here to... Nope, I don't have my calculator. All right. So 17/4 is 4.25. I'll just put square root of 17/4. And this is going to be a little bit more than 2. Okay, this value here is radius is just a little bit bigger than 2 point something small. I don't have a calculator here to give me that value, but that's all right. All right, so -3/2 1. Now this is -1.5, so 1.5 and then 1. Here's our radius, or here's our center. Now, square root of 17/4, all right, is, I checked this value here, that's 4.25, so if we square that, it's going to be just slightly bigger than 2, so I'll just do this here, 1, 2, a little bit more, 1, 2, a little bit more, 1, 2, a little bit more, 1, 2, a little bit more. That's good enough for this example. Sketch it. Okay, and I think we'll just call that good. So, purpose of this video here is to help you understand how to graph circles. And again, what you do, especially when they start out something like this, is you have to complete the square to put them into standard form. Then you identify the HK values from these numbers. You identify the radius. It's going to be the square root of whatever's on the right-hand side. Go to your center. Go right whatever the radius is. Put a dot, up, left, down, put dots, and then sketch the rest of it. That's pretty well it. That's good enough for now. I hope that this video helps you understand how to sketch graphs of circles. Have a great day.